drawing cylinders. This is one of the most basic kind of drawings to do, but it's really important to know how to draw cylinders well and how to measure the ellipses in particular at the top and the bottom of the cylinders in order to make your drawings look realistic. So we're going to talk you through some of the basic measuring techniques first. It's really important that you have good understanding of how to use the skewer or your drawing pencil as a measuring guide. And I've got another object here that could be fun for you to check out as well. So I'm going to show you, I'm going to share a screen here with you and show you some images here. All right, so one of the most important things to remember as you're lining up to draw is to get your object far enough away from you that you can measure it with your arm straight. It's really important that your arm is straight, because if you are taking one measurement with the skewer far away from your eye, and then without thinking about it, you bring in the measuring tool as you're taking a second measurement, then it defeats the purpose of measuring at all, because your measurements will be wrong. So it's really important every time you take a measurement or compare the height of an object to its width, you want to make sure that your elbow is locked to make sure that your measuring tool is not changing scale as you're taking measurements. The second thing to do is, I guess I read them out of order. The first thing is close one eye so that you've got a monocular vision of the object and you're not seeing two images that are slightly different angles from one another. And the third thing is to try to maintain a perpendicular angle between the angle of your arm. Let's see if I can show myself here. The angle of your arm and the angle of your measuring tool, whether that be your pencil. Later on, we're going to be using these L tools that are built out of pieces of mat board. And that's also really important to keep a right angle between the measuring tool and your arm. That prevents the measuring tool from being foreshortened, which is also going to make mistakes in the way you measure. So try to imagine a plane of glass at the end of your arm that you will be resting your measuring tool up against the glass, and you can, if you're checking for angles, you can turn the measuring tool as if it were the hands of a clock, but you should not point through that pane of glass, that imaginary picture plane, as you're taking measurements. So those are just some good basics to always keep in mind as you're measuring, to make sure that you don't get distortions in your image. Another thing to think about, and I added this little diagram of my husband drawing to help you kind of imagine what's happening there. So he is closing one eye and he's lining up the back edge of the glass. That'll probably be the highest thing that you're seeing in the picture. And then he's moving without changing where the position of the top of the measuring tool is. He's sliding his thumb down the skewer until his thumb aligns with whatever he's trying to measure. So in this case, he's measuring just the bowl part of the wine glass. He's not measuring the stem. And so he doesn't even need a ruler. It doesn't need to have measurement marks on it. He's just looking for a base measurement. So that bowl of the wine glass is going to be his unit of measure. And he'll use that over and over again to compare other parts of the wine glass. So he might plot out how large the bowl of the wine glass is, and then without moving his thumb, he can shift his whole skewer down and count off how many of that distance will fit into the full height of the wine glass. So here's a picture of what it might look like from his point of view. He's aligned the top of the skewer with the back edge of the bowl, and then he's sliding his thumb down until it lines up with whatever point he's trying to measure. So he's not quite at the bottom of the bowl there, but I was trying to figure out how to shoot that through my camera. It's a little bit off. So once you've got a measurement on your skewer that represents the height of that bowl, I've drawn a red arrow here, and then what you're going to do is keep your thumb there and then compare it to other things. So here we notice that the whole height of that wine glass is about 2 bowls tall. So it's about, that stem happens at about the halfway mark when you're looking at the height of the glass. The other thing you might notice is you might take one measurement vertically, let's say from the top of the rim of the bowl to where the stem attaches, and then without moving your thumb, you can turn the skewer the other direction and just compare. So you're just trying to notice, is the width of the bowl greater, or is the height of the bowl greater? In some cases, they may be the same. And I think in this case, they are very close to the same measurement. So we could even plot out that first part of the glass as a square. You know, again, we'll be adding the curves later, but you're kind of thinking like a sculptor might think, and you need to get that basic rectangle figured out first, and then we'll chisel away to find the shapes within that rectangle. The other thing you can use your skewer for is to notice how different parts of the object align. So you can use it as a kind of a reference for what a true vertical would be, almost like an architect or a house builder would use a plumb line to compare, you know, whether your wall is straight up and down. And as we use a skewer at the edge of that wine glass, we can see that the base of the wine glass is a little bit narrower than the belly of the wine glass. And it seems like the very mouth of the wine glass is also a tiny bit narrower than the belly. So using your skewer as a reference for a true vertical or a true horizontal is another good strategy for using that measuring tool. So here we have a glass. This is maybe the more expected view of a wine glass, where it's sitting on the table slightly below our eye level. And the idea of eye level is also a really important thing to know about in drawing. So it will affect the proportions of the ellipses that are on our cylinders. As the objects get closer to our eye level, so again, eye level is an imaginary plane that is parallel to the ground plane. So if your head tips up the horizon line, and eye level is going to still stay parallel to the ground plane. But it depends where the object is relative to that imaginary eye level. So in a lot of situations in a still life, the objects will be below our eye level, and so we'll be looking down on the top of the objects. But there are situations where maybe the wine glass is actually a little bit either all completely above your eye level, and I'll show you a picture of that in a second, or it could be that your eyes meet somewhere in the middle of the wine glass. And in that case, I'll show you a picture here. This shows you what it might look like if you had water in the wine glass and you had your eye level right at the level of the water. So we're actually looking up at the front edge of the wine glass, the lip, and the water level appears to be a straight line. We don't see it as an oval or an ellipse. And then this is a really unusual view of a wine glass, but it would be if the wine glass were up above our eye level slightly, and we can actually see the bottom of the foot of the wine glass. So for your homework, I'll be asking you to try drawing different cylindrical objects from all different angles, some laying on their sides, some up above our eye level, some right on our eye level, and some below our eye level. So how do we get started? Let's go back, and I'll stop sharing my screen so you can see me do the drawing. So this is a photograph. You're going to actually be working from real objects, not from photographs, but I couldn't figure out a way to let you see what the glass looked like in front of me. So this is going to represent what the view in front of you looks like so that you can see how I'm taking measurements in real life. You'll want to have a couple of erasers. These are both kind of firm erasers that are good for erasing dark lines. And a kneaded eraser is also a really handy tool. So this is like a piece of, it almost looks like gray clay, but it's very flexible and malleable. And as you stretch it, it will clean the eraser for you. And I really prefer these over the kind that crumble on your paper. You'll also want to draw with either a mechanical pencil, which gives you really nice precise lines, or you can choose a little bit softer pencil. Because it's hard to videotape drawings on white paper, I'm going to draw with a super soft pencil, but I usually don't prefer pencils that are quite this soft because they tend to smudge all over the place. So usually for your drawings, I'd prefer that you use a 2B or maybe an HB, which is similar to a number 2 yellow pencil. So the first thing I want you to do is to sight. So you're going to be holding your skewer out in front of you, and I'd like you to first determine the overall width to height of your object. So we're going to just try to locate a rectangle on our paper. I also want you to be able to enlarge the drawing. Normally, if the object is far away from you, when you take measurements on the stick, they might just be, you know, a ½ an inch high or 2 inches high, and we've got this huge piece of paper. So I want you to learn to enlarge those proportions to fill your page, and then you have more control over the scale of your drawing instead of being a slave to whatever the literal measurements were on the stick. So what we're looking for is a relationship between the width of the object at its fattest point and the height of the object. And once we find that basic proportion, we can draw that rectangle any size we want. As long as it doesn't get stretched out or too squat, it will stay in proportion. So what I'd like you to do in real life is line up one edge of your skewer with the widest part of the object, and then move your thumb along until it aligns with the edge that you're trying to measure. Now, without moving your thumb, you're going to change direction, and we're going to count off how many, and again, I'm just going to keep this here as a reference point. We lost focus. We're going to figure out how many of those heights, I'll bring it to the middle here. So in your mind, you're just going to look for a reference point. You don't have to actually, you're not going to be able to draw on the real object in real life, but I'm just noticing, okay, that ends about where the stem starts, and we'll count off. That's really close to two of the widths fit into the height. So as long as I build a rectangle, and again, it's fine to have lots of sketchy lines in here, just work kind of loosely, and I've drawn some light guidelines just to establish kind of a random width. But now that I've chosen that distance, I'm going to refer to that as my unit of width. So some students like to draw marks on the skewers. I try not to, because otherwise you get a million marks and you lose track of where you are. So just use your thumb as a reference, and I'm just going to randomly choose a spot where I want the base of the glass to lie, and then I'm going to use this width. I know that it needs to be about twice as tall as it is wide, and I'll just sketch out a light rectangle. I might even keep this halfway mark as a reference. It's fine to have some of this history of your drawing in there. Now, we've already noticed that this glass is about as wide, the bowl of the glass is about as wide as it is tall. So we're just going to use this sort of as the reference for that bowl. So again, we can be kind of loose at this point. We might have to refine it a little bit later. And then what gets a little bit trickier is trying to figure out how to draw these shapes. So what I'd like you to do is think about the different ratios of these ellipses. So what we need to do is find a relationship between the height of the ellipse. So there's a long axis on the ellipse that goes this way, and there's a short axis. So if you think about it as crosshairs that run through the middle of the ellipse, we're going to be comparing the height of the ellipse to its width. So we've got to count off how many of these, better use my other hand because will fit across the width. So you're just kind of, again, in real life, you're not going to be able to draw on the object. You're just going to have to try to notice where and do your best to kind of count off. So I usually kind of imagine that I'm taking a little tack mark and just keep in my mind sort of moving across to estimate. So, in this case, it seems that this ellipse is about 4 times as wide as it is tall. Now, we've already decided how wide we want that glass to be, so we have to work backwards now and estimate what 1/4 of that would be. So usually what I do is I kind of estimate where the center is, and it's really good on most of these cylindrical objects to find that center line anyway, because most things are pretty symmetrical. So draw that line in. And then we're going to, we already know this is representing the full width of that ellipse, and we know that it needs to be 1/4 as tall as it is wide. So what I'll do is kind of estimate what 1/4 of that might be. So if you want to use a ruler to just kind of check your measurements, you can, but estimating is usually pretty good. So this distance is about 1/4 of that width across. So what I want to do is we'll keep this point where it is the back edge of our ellipse, and I'm just going to use one of those 1/4 of that distance and aligning one edge of it with that top lip. We'll mark where the bottom of that ellipse needs to be. I also like to know where the center line of the ellipse is, because we want our ellipses to be really symmetrical. So at this point, it's just a matter of connect the dots. We're thinking of 4 points where that ellipse will fit inside that. And sometimes I have to draw it a few times to make sure it's nice and smooth. You don't want to have ellipses that are lopsided, so that's not too bad. Some of the problems with drawing ellipses are, one common problem is thinking of it as just 2 halves, and students come up with these really pointy ellipses. You don't want it You don't want it to look like a lemon or an almond shape. You also don't want to just keep it straight across and then round off the ends like a hot dog. That's not good either. And the third common problem is that they don't make them symmetrical. So you might find these loaf of bread kind of ellipses where one side is really flat and one's really rounded, but it's not symmetrical. So if you drew a line through the widest point, you'd have a lot more distance on one side of the ellipse than the other. So these are all kind of foods that you should avoid. No almonds, no hot dogs, and no loaves of bread. Try to keep your ellipses really as symmetrical as you can. So they should look the same on the right and the left, but they should also look the same on the top and the bottom of that area. All right, let's go ahead and just kind of darken in some of this. Again, you can keep your drawing kind of loose so that you can make room for corrections. Now we need to check this bottom ellipse. And because this ellipse is farther from our eye level, it should be closer to a circle. That's a really common error that students will do, is they aren't paying attention to how much flatter the ellipses are as they get close to their eye level and how much rounder they are as they get farther from our eye level. So again, we'll be measuring, even though we can't see the back edge of this ellipse, you have to try to imagine where it actually would be in real life. And then again, measure the height of the ellipse, the short axis of the ellipse, and estimate how many of those heights will fit into the width. And this one seems like it's 1 to 2. So it's about twice as wide as it is tall. I also want to make sure that I'm not making this base too wide, because I know from just looking at my plumb line that the base is a little bit narrower than the belly of this. And if I want to be more precise, I should just measure the two. And again, you don't need to use a ruler that has measurements on it, but you can use your skewer or your pencil and just take note of how wide the base is and compare it to something that we've already drawn. So we know we've already drawn this distance, and this seems to be maybe 2/3 of the distance of that original bowl of the glass. So if I go back to my drawing now and kind of estimate, what would 2/3 of that look like? So I'm a little confused by the middle line, but if I kind of estimate, okay, maybe this is thirds. I could take 2/3 of that, mark it with my skewer, and then bring it down here, and we'll try to center it on our middle line so that it stays symmetrical. So just kind of estimate. Another way I can double check is, this distance and this distance should be pretty similar if I've got it centered. And then I also want to know, so we know that I said that the height of the ellipse is about half of its width. We've just drawn out what the width needs to be. So if I use the center line, that should give me about half of that distance. And I could double check. Yeah, that looks not too bad. So without drawing on there, I'm just going to use that distance to help me estimate where this ellipse needs to be. So you can, if it helps you, draw a light rectangle first. Sometimes that helps me to kind of keep my ellipse symmetrical. It's also really important to know where that center line is, because it becomes the widest part of the ellipse. So we're looking at points here at these 4 intersecting points, and then we're going to try to do a nice smooth ellipse there. So you can draw lightly if it helps you to just kind of think portion by portion, quarter at a time. But again, try to make the only place that ellipse should be touching these 2 guidelines is right at the middle. From there on, it should start tapering down. So don't keep it horizontal too long. It should really start to transition into a curve right away. Okay, so that's, maybe somewhere in the ballpark. All right. The other thing I might do is notice some of these other points, like how wide is this point where the glass broadens out? So, or I might be trying to measure some of these other things. So you're going to be taking quite a few measurements, but having a center line is super important. Knowing where the center of each ellipse is really important to help your ellipses stay symmetrical. The other thing you might do is force your eye to look into this empty space. This is called the negative shape. And if you can draw that negative shape pretty accurately, it'll help you get the curves right on the object itself. So, I'm going to kind of lightly draw my first attempt at this, and then if it's a little bit off, I can make it skinnier or I can make it wider. But when you find a line that you like, then I want you to go in, darken it up a little bit, And it could be that this line, you know, maybe ends up just kind of gracefully curving into there, and there may be another spot where I see a little bit of a ellipse here. I try to keep it also about the same proportions, even though it's smaller, I keep it about the same proportions as this other ellipse that it fits within. And then there may also be a small ellipse here that I create that I see here a little bit, just to kind of help. But there we've got a pretty good representation. You know, this bowl might not be quite perfectly shaped right. It might be a little bit fuller toward the base, but I think that's a pretty good representation of the object that we're seeing. You might also notice that there's sort of a thickness to the glass down here. So if you wanted to suggest that, you could come in with a second ellipse just a little bit above the first one that we drew, and that helps create a more convincing sense of thickness here at the base of the glass.